TensorFlow.jl. So first up, why TensorFlow? TensorFlow has all the manpower of Google behind it. So if you can have a Julia wrapper for TensorFlow, then you can enjoy all the manpower that Google and the open source contributors give to TensorFlow in Julia. TensorFlow, it's got a Python API. Why would you want to use the Julia API when there's already a Python API? One is TensorFlow is Julia's multiple dispatch system. A second is Julia's macro system. And the third is Julia's just-in-time compiler. And I think when you add these up, you can make a really nice interface to TensorFlow that is at least as good, and I would argue better than the Python API. So I think at this point, the most convenient interface to TensorFlow is actually the Julia API. And I'll give some examples. OK, so just a brief introduction to TensorFlow. There's lots of tutorials out there. So TensorFlow uses a static graph framework. So here I'm saying there's this variable x. It's a placeholder whose value I'll give later. There's this variable y, which is 1 plus x. No computation has actually happened at that y equals x plus 1 line. But when I call this run function, that's actually going to perform a computation. Let's try a bit more complicated example. So you'll notice this macro in front of my model now at TF, standing for TensorFlow. And this is going to cause some magic to happen. So here's my model. Let's run that. OK, so I built up a small computation graph. It's got 3 nodes. It's got x, which is holding this constant. It's got y, which is x plus 1. It's got z, which is the sine of y. Let us visualize our static computation graph with this visualize function. So this is TensorBoard, the visualization framework that ships with TensorFlow, which TensorFlow.jl will automatically utilize with this visualize function. So you can see here's my static computation graph. It's got this y node, and it's got this z node. But wait, where did those names come from? How did TensorBoard know to call one node in my graph y and one node z? Well, it's because that was the name of the Julia variable that was used to store those nodes. And it's because of this TensorFlow macro that that's able to happen. OK, what is so great about using multiple dispatch? Here's a function in Julia. Got my f of x. It's the sine of x. Looks like a normal Julia function. I can call it on a Julia value. That works. All right, now I'm going to call it on a TensorFlow node. So constant 2.0, constant means create a TensorFlow variable. So once it's wrapped in a constant, TensorFlow has taken control of it. I might have moved it to the GPU. It's not a normal number. But I can still call f on it. And I get back a TensorFlow tensor. Then I ask that tensor to evaluate. And it just works. Let's look at some control flow. So I want to take the sum of the first 10 integers squared. What can you do in Julia with Julia's macro system? What's this? A native Julia while loop. Here, all right, you got your very natural while loop. That just works. So you can actually have control flow in a static graph framework. I'm going to talk a bit about the internals. So TensorFlow.jl is a wrapper. But you might say, well, if you're writing a wrapper, it's always going to be behind upstream TensorFlow. We have code that will automatically import all core TensorFlow operations into the wrapper with no additional work. Any innovation that Google contributes to how TensorFlow decides to execute operations is going to apply here too. By using TensorFlow.jl, you get all of this work that Google engineers have put into things like TensorBoard. So imagine how much work it would be for one person writing their own deep learning library for Julia to write something like this. That'd be a ton of work. But it's like hundreds of man-hours went into having really good visualization right out of the box. And you can benefit from that by using the wrapper. Thank you.